First, we're going to use the vertical line test, and the reason why we're doing that is because it's the easiest to test if something is a function. So here we have three different graphs. Okay, so here are three different graphs. Now what we're going to do is we're going to be responsible for determining if it's a function or not. Now the great thing about a vertical line test is we can check that if we have a graph. So the question I want you guys to think about as we use this vertical line in red is how many times is this vertical line touching the graph simultaneously? Okay, so as we move it along, notice it's touching the graph right now, but it's only touching it once. It's touching the point, or it's touching the graph right here, and it's only touching it there at that given time. Now I know that as I move this line, it now touches it at a different spot, but because it's still only touching the line at one point at this particular instant throughout the whole thing, we can call this a function. So this one is a function. The next example is right now it's not touching the graph at all. Here it's touching it only once. So at this point in time it's still a function. As we scoot it over, notice it's touching it twice. It's getting touched here and here. And because this vertical line is touching the graph twice, that means it is not a function. Last but not least, we'll try it on the last one. As this vertical line goes through the graph, notice it's touching once, still touching once, still touching once throughout. So because it only touched this graph once at any particular instant, this is a function. So that's the vertical line test. We're going to actually move this stuff over for a sec to talk about how we would do this if there is no picture. So I'm going to make a duplicate of this so we can try it a couple times. Now here's how this works. The domain is our x values, our ranges are y's. Now the way that this works is that we're going to start to draw lines or points, lines from one number to the other. Now 1 is going to go to 2, 3 is going to go to 7, 4 is going to go to 4, and 5 is going to go to 8. So this is oftentimes how you'll see the picture. Now because each value in the x values right here is only going to one value for the range, then it is a function. As soon as I take this -1 or any of these numbers in my domain and have it pair with two different numbers like it is right now with 2 and 4, as soon as this happens, the graph is considered not a function. So the analogy I use is pretend our domain are the guys or boys and our range is the girls. Now, the range is girls. Now the analogy that we use to help make this a little bit more clear is that as we go through this process, each guy is going to be dating or is paired with one girl. So if this -1 guy is dating number 2, and 3 is dating 4, and 4 is dating 7, and 5 is dating 8, that's all fine and dandy because each guy is paired with one girl. But as soon as one of these values, say the 3, the guy number 3, starts to date two girls, this is considered not okay, and that means it's not a function. So this is not a function because one guy can only be paired up with one girl, not two. So let's try another example. -1 is paired with 4, 3 is paired with 7, 4 is paired with 8, 5 is paired with 2, 5 5 is paired with 8 also. So notice, number 4, the guy number 4 is going towards girl number 8. Guy number 5 is also going towards guy number 8. Now, because no guy is cheating, or no guy is paired with 2 girls, then this is still a function. So this one is a function. Let's try another one, and I'm going to give you some time to try it on your own. So 1 is going to be paired there, 3 there, and question is this a function? And the correct answer is yes, it is a function. Now it's your turn. Try the following 3 problems, and once you're done, please post your answers to Edmodo. First person will start, everyone else will reply. That's all for now. I'll see you guys next time.